Today we're going to take a look at the derivatives of periodic functions, and in particular sine and cosine. So let's start with example 1, just taking a look at the graph of sine, and from that sketching a graph of the derivative of sine. Okay, so if you recall, the derivative is the rate of change of a function, right? It's how y is changing with x, right? It's this, and it's the instantaneous slope at any given point. And if we were to, sketch a tangent line, the slope of that tangent line at any given point would be the derivative at that point. Okay, so keeping that in mind, what we're doing, what we're going to do is graph the slope of this sine function at any given point. All right, so I've made the picture a little smaller just so that we can see both the graph of the function and the graph of its derivative, which we're going to sketch on the same screen. Now I've arranged these vertically, just because I kind of like to be able to show the correlation between the points. So if I can take a value at one x-coordinate and drop straight down to the other x-coordinate on the other graph, so you can kind of see what's happening. So that's why I've got it arranged vertically instead of horizontally. But anyway, so we want to graph the instantaneous rate of change of this function, sine of x, right? So we're going to graph the slope of the function. So let's take a look at the original function, sine of x. Now you can see here in this portion of the graph, right, the sine of x is increasing, right? Which means that its slope is positive. All right, and then it turns around at this point right here, right? And then you can see here that the slope is negative, right? Right, so that means that our derivative is going to be negative. And then it turns around at this point, right? And the slope here is 0, and now it's increasing again. Okay, so the slope is going to be positive. And then again it turns around, and so on, right? And it's negative again. All right, so when the slope is positive, right, then our derivative is positive, which means it's above the x-axis. Okay, so so our graph is going to be above the x-axis, and then it changes direction, right? It goes from increasing to decreasing. And in this area where the slope is negative, right, it's decreasing. The function is decreasing, the slope is negative, right? And so it's below the x-axis. And in between there, the slope is 0. So right here at this point, which looks like it's about negative 3 pi over 2 in this particular case, the slope is 0, right? And so that's where it's going to cross the x-axis. So we can just drop straight down here to negative 3 pi over 2, and we know that it's going to cross the x-axis. And on one side, the slope is positive, right, because it's an increasing function. And then on the other side, the slope is negative, so it's below the x-axis, and it's decreasing. The function itself is decreasing. Okay, so that gives you an idea of what it's going to look like. Now it comes back here. The slope turns around again here at, this looks like negative pi over 2, and then it's positive again. So here at negative pi over 2, we have to cross the x-axis again, right? So it's going to come back and look like this. All right. Now the slope is positive again, and it's positive all the way from negative pi over 2 to pi over 2. Okay, slope is positive, so the function is increasing. So that has to be, the graph of the derivative has to be above the x-axis for that whole period. So here's pi over 2, and we have to, we're above the x-axis. I'm just kind of sketching this in. You might be noticing a pattern here. All right, now on the other side of pi over 2, the slope is negative, so it's below the x-axis. So we're going to come down, and then it looks like this is going to be 3 pi over 2. At 3 pi over 2, the slope is 0 again, right? So that occurs when the slope goes from decreasing to increasing, right? So the slope of the original function goes from decreasing to increasing. So the derivative changes from negative to positive. And now we're going to be above the x-axis again, right? Because the function is increasing, right? And the slope is positive. So the slope of the derivative is going to be above the x-axis. All right. So there's a rough sketch of the derivative of sine of x, and it may look familiar to you, right? This looks very much like the cosine function. And I've kind of intentionally made it look even more like the cosine function by making it come all the way up to a maximum of 1 and a negative minimum of -1. But in fact, the derivative d dx of sine of x is equal to the cosine of x. All right? You just have to take my word for that. It looks like it, right? but take my word for it. The derivative of sine is cosine. All right. Take a look at the next one. The next one is just cosine, right? It's the same thing. I want you to go ahead and try this out. Try to sketch the graph of the derivative of cosine and see what it looks like. And I'll meet you in the next video.